Okay, question number 13, let's get right into it. So this is a really interesting question because you're going to have to use actually a little bit of graph theory. So it says, let G be a graph such that every two distinct vertices in G are connected by exactly one edge, and every edge connects two distinct vertices. If G has 190 edges, how many vertices does G have? All right, so let's start out with just kind of a model graph here. So let's say that we have 4 vertices, and these are all distinct vertices. Now, if we connect each of them uniquely, I'm going to get something that looks like this. Now, there's something called a degree of a vertice, and the degree of each vertice is basically just how many connections are connected to it. So if I have, 1, 2, 3 connections per vertice, that means that each of these vertices is going to have a degree of 3. And because we have this condition where every single vertice, how do I say this? Two distinct vertices in G are connected by exactly one edge, and every edge connects two distinct vertices. That means that every single edge is actually going to have the exact same, or sorry, not every single edge, every single vertice is going to have the exact same degree. So if you look at this, you'll see that, okay, all of these have the degree of 3, right? And I have 4 vertices total. So I have 4 vertices and all degree 3. So let's go ahead and try expanding this a little bit. And this is just kind of something that you should know, but let's just try and kind of expand it a little bit and see if it works all the time. So what happens if I have something with 5 vertices? So let's see here. So if I have 5 vertices, I would expect that the degree for each vertice is going to be 4, but let's see if that's really true. So if I connect all of these uniquely here, I can actually do quite a few connections. So let's see here. Let me just make sure that I get all of them. I can connect here. And I believe that is everything. Yep. Okay. So my prediction here is that if I have 5 vertices, I should have all vertices degree 4. So let's see if that is true. Let's see. So I have 1, 2, 3, 4, 4 here, 4 here, 4 here. Yeah, that is true. So from this knowledge, what we can do is I can go ahead and say that given our conditions, let's see, the degree for all vertices is going to be equal to the total vertices minus 1. Wait, is that right? No, sorry. Whoops. Sorry, guys, not minus 1. 1 plus the degree for all vertices is going to equal my total vertices. Because see, right here it's 3, and I have 4 total, so I need to add 1, right? So we know that this kind of, I guess this statement has to be true, okay? Now the other thing that you should know, but I'll just go ahead and show you, is that here, let me go ahead and write it out. The number of edges, if I take the number of edges and let's see here. Hang on, let me make sure I do this correctly. Yeah, okay. So the number of edges, if I multiply it by 2, this is going to equal the sum of all vertice degrees. Okay, so now that we know this is true, 1 plus the degree for all the vertices is going to equal the total number of vertices, and then 2 times the number of edges is going to equal the sum of all vertice degrees. And look, we're just going to show that here. If I have 3 plus 3 plus 3 plus 3, I'm going to get 12. So I have 12. That's my sum of the degrees here, and I have, let's see here, 1, 2, 3, 4, 5, 6. 6 edges. Well, if I multiply that by 2, I'm going to get 12 equals 12. So this relationship holds true. So let me clear some space and let's go ahead and put it all together. So if I'm given that my number of edges is 190, then I have 2 times 190 is going to equal the sum of all the vertice degrees. Now, I don't know how many vertices there are, right? So I'm going to say, all right, I have n vertices. Now, the thing, though, is that, well, actually, you know what? Let me write it like this. It'll be a little bit cleaner. I don't know how many vertices I have, but I don't know what the highest degree for the vertices is going to be. So I'm going to call the highest degree, I'm going to call that n. Now I know that the total number of vertices is going to be n plus 1. So it's going to be n plus 1 here. Okay, so now that we know this, I'm going to go ahead and erase these assumptions here. Give me some more room. Okay. All right, so now that I know this, this is just a very simple algebra problem. So I'm going to have 2 times 190, which is 380. And this is going to be equal to n squared plus n. And then if I subtract 380 from both sides, I will now have that 0 equals n squared plus n minus 380. So if I have this, this is just a quick factoring problem. So when I factor this out, I'm going to get n plus 20, and then n, let's see, n minus 19. Now, whenever I solve for n, I'm going to get something weird. I'm going to get a negative value. So I have that n equals negative 20 and n equals 19. But we're just going to take the absolute value of n here. So I'm going to have n equals 20 and 19 is my answer. Now, my question is, okay, well, what is the number of vertices? Is it going to be 20 or 19? And we know the number of vertices has to be 1 greater than the maximum degree. So this is our maximum degree, and this is our total number of vertices. So our total number of vertices is going to be 20, and the correct answer is going to be C. All right, guys, so that is the correct answer. Kind of a longer video, but if you have any questions, feel free to comment below, and I will see you guys in the next video.